All right, what's going on, YouTube? KG4FJC. Yes, I got the hat. All right, I'm playing all kinds of stuff here. So let me get out the way that. All right, the laser engraver's running, fans running. You can see that in the background. Got another radio on. It's quiet at the moment. Anyway, what we're going to do is we're going to do another series of videos. This series is going to be on duplexers, what they are, why you may or may not need them. Honestly, if you're not doing repeater work, you probably don't need them. But if you're wanting to play repeaters, you're probably going to need them. So we're going to get into what they are, why they're used, how they're used, and later on in the series we'll get into the technical side of things as far as how you use them, how you tune them, and all the nitty-gritty of that stuff. But as always, we're going to make it nice and simple. So without further ado, I like that word, let me transition. Boom, magic of computers. Okay, a duplexer, what it does, generally speaking, is it allows one antenna to do both receive and transmit at the same time with two very close frequencies. Okay, not the same frequency, but on the same band. In this picture, it's UHF. It's UHF. So I don't claim any rights to any of these pictures. I Googled it and stuck it up. So there you go. Don't sue me. Okay, so that's what it is. It allows your transmitter to transmit out the antenna while at the same time your receiver over here can hear this weak little potato thing 10 miles out from the repeater with somebody in their basement or whatever. All right. So let's start from the beginning. Somebody transmits out here, your antenna picks it up, the signal comes down, and it comes down to a physical T. The transmitter and receiver are mechanically, the center pins are connected to each other. If this was DC, it would go poof and let the smoke out, but it's AC, so we can have some fun. So your weak signal comes in here, okay? It tries to go both ways. All right, first, let's go this way. It's going to try to go this route, and it's going to get here. Now, what happens at this point is this a duplexer cavity, all right, what it's doing is it's going to stop or at least attenuate some of that signal, all right, because you don't want the receive signal going this way, all right, because that's going to the transmitter. Okay, so it's going to attenuate a little bit. It's going to attenuate a little bit more, and so on and so forth, for as many sets of cavities as you have, okay? So since this is being attenuated, it can't really go that way. So let's look at this way. Well, it comes down this way, goes here, all right, this is tuned for this frequency, so it allows this frequency to go through, and so on down the line. So your receive signal comes in, goes through here, all right, and these are just notch type duplexers. We'll get into the different types later, but this is just generally speaking. Okay, so your signal comes in, your receiver hears it, okay, tells the controller, which would be in the middle, to light off the transmitter. Okay, now your receiver is hearing this signal, but your transmitter just turned on. Okay, and remember, these are connected together on one antenna. So your transmit signal goes out. Okay, even though your transmit signal is on this frequency, the frequencies are close together, your receiver's gonna hear it if it's directly connected. So what it does is it comes out, it hits this first cavity right here. Okay, this first cavity says, okay, I'll allow this signal to go, but I'm not allowing this signal to go. So it allows it to go right on through. Okay, and at the same time, any spurs or dirtiness or what have you on your transmitter signal, if it's close to this frequency, it's going to cut it out. But anything that's right at this frequency, it's going to let it keep going. So it does that through all of these cavities. All right. Now here, it can go two ways. Okay. Let's assume it's going to go straight. All right. Well, it goes straight until it hits this cavity right here. Okay. Notice this is in red. This cavity is going to block this signal right here. Okay. Or it's going to attenuate. It's not going to stop at all, but it's going to seriously choke it down. All right, a little bit more gets through. This cavity right here, same thing. cuts it down again. All right, this cavity, same thing. It cuts it down. By the time it gets here, it should be cut down enough where the receiver actually doesn't even hear the signal. Okay, it may still be there, but you're receiving on this frequency and you're transmitting here. Okay, so since it can't really go this way, all right, the only route it can really take is out the antenna and transmits out. So in a nutshell, that's pretty much how they all work. All right, again, this is a notch type. We'll go through the different types. Actually, an example right here, this is a notch type duplexer. Again, we'll get into that. So that's how they work. Let me close that, and here is again your notch type. You see your low and your high. Depending on your offset direction, your receiver, transmitter, or receiver, transmitter, either way, and then your common out to your antenna. Okay, that's how, generally speaking, duplexers work. Now, you've got other types like these here. Make this picture big. Okay, these are band pass, band reject filters. Okay, now, when I say that, let's look at a scope of a notch. Okay, remember the red and green from the other picture? This might actually be from the same person. I don't know. Another one I just found. Okay, this frequency here is being attenuated, and this frequency here is being attenuated. Okay, everything else can pretty much pass unobstructed. All right, these are great if you have a RF clean environment, meaning there's not a lot of noise, because your radio front end is doing all of your selectivity. It's going to keep any not so strong signals out that are off frequency. It'll do an okay job depending on the receiver, but basically your notch style or band reject filters, all they are is they are attenuating the receive frequency from your transmitter frequency, and they're attenuating your transmit frequency out of your receiver. That's the main thing, is it's keeping the transmitter out of the receiver. The downside to those is that if you are in a noisy RF environment, everything else passes right through. Any other frequencies pass right through. So you're strictly depending on the front end of your receiver to be able to keep the other stuff out. Actually, let me turn me a little bit. So they work great if you're in a clean environment. The good thing is that the notch style duplexers or band reject, they don't really attenuate any of your signal in either direction. Very, very little. So basically everything going in is coming out both directions. Great. But if you got a high noise, it's going to suck. Commercial sites, everybody's on a mountaintop, so everybody wants to be up there. Well, with all the other noise, you have a hard time hearing. It's just flat out, you just have a hard time hearing. So then you have band pass, band reject filters. Okay, and that's this style here. All right, what these do is they do the same thing as the band rejects, the flat packs. They cut out the transmitter from the receiver and vice versa, so you don't have that. But what they also do is they cut out everything out of specifically what you're looking for. So your receive signal coming in, wow, my laser's done already. Your receive signal coming in, same thing, except for now it's going to look for the easiest path, and that's going to be through the cans that are properly tuned. But any other noise out of band or even close, the quality of these counts. It'll cut that noise out. Okay, so if you have something, let's say you're at all right, I'm just going to spit numbers. Let's say you're receiving at 200 megahertz even. All right, exactly. And you've got something at 220 megahertz very nearby your receiver. Okay, your receiver is going to get flooded. It's not going to hear. If you're using a notch style filter, it's not going to hear that weak signal. All right, all it's hearing is the noise from that 220 megahertz signal. All right, it's not hearing the 200 megahertz. With these, what it's going to allow you to do is the receiver will only hear just a very, very small window of that 200 megahertz. So you'll hear, your receiver will hear, again, just spitting numbers, let's say 195 megahertz to 205 megahertz. So that's all your receiver will hear. Therefore, you don't have to worry about that transmitter that's right next door to you. The problem is that by doing that, you also introduce loss through the cans. It's typically about 1.5 dB. Doesn't sound like much, but 1.5 dB is considerable when you're looking at pulling weak signals out. The same for the transmit side. It only allows a very small window of frequencies to go through, whereas on the notchplexers, they allow everything except for that one little teeny spectrum that you've notched out for your receiver. It allows everything to go through except that. Well, a lot of transmitters are, honestly, they're pretty freaking filthy, and China stuff is really filthy. With these, all right, this isn't the end game, but these help squeeze down that pass band, if you will, so that you've only got a small, narrow window of frequency going out. That way you're not going to interfere with other stuff. There are other things that need to be done to help do that, but that's deeper discussion. So that's basically what they do. And here's another design. This is I'm not even sure. I ain't zoomed in enough to read it. This is probably like 800 megs, something like that. But you see, you got your port here. All right, your common, your antenna port, and then input and receive, or vice versa, whichever way it's set. That's basically how they are. And real quick, yeah, this picture will work. Let me zoom back in. All right, these cables that connect each set to each other, they're a specific length. You can't just slap a piece of RG8 on there and say, oh, it's good. It's not going to work. In order for these cans to cooperate with each other, this cable has to be, I believe it's a quarter wavelength or quarter divisible electrically between the two. But then again, that's more theory and more detail. So let's see, here's another diagram that, again, just found it somewhere. I was going to use this, but I didn't really like it because it shows the arrows going all the way through, which it's not. You got transmit and receive. It's just the receive is going here, and the transmit can go here without actually going here. So that's really what it is. Again, that's just a quick introduction to what duplexers are and how they work. Again, you've got your band pass, band reject. Those are expensive. Look them up. They're expensive. Those are great for a noisier environment, a serious repeater, because they block out a lot of everything that you don't want and only allow a small window of what you do want. Okay. The notchplexers, the flat packs, whatever you want to call them, they work great in a fairly quiet environment, but then you're dependent solely on the receiver front end to block out any other noises that are, any other frequencies that are coming through. And that's, again, in a quiet environment, it's not a problem. But if you get on a mountaintop, noisy environment, your receiver's just going to be overloaded with so much crap, it's going to hurt your sensitivity. Your receiver's probably going to be opening up for stuff it shouldn't. But the good thing is they're cheap, a lot cheaper, and there's just a slight insertion loss. There's not a lot of loss through them. So both of them have pros and cons. I hope that helps with kind of what a duplexer is. Again, we're going to do a series here. I'm not sure how fast I'll be able to crank them out, but more series to come for duplexers. What they are, how to use them, when to use them, how to tune them, and all that goodness. So with that, we're going to say 7.3 for now. Kept it short. Catch y'all later. KG4FJC.